Hello, my name is Michael Maksimovich, and I'll be teaching you how to solve the 2014 BC Calculus FRQ number 2. For this FRQ, you will need to know some key fundamentals, such as polar equations and graphs. So for polar equations, you need to know x equals r cosine theta, y equals r sine theta. The tangent of theta equals y over x. Also, r squared equals x squared plus y squared. You also need to know the area and arc in polar coordinates, which is 1/2 of the integral from theta 1 to theta 2, r squared d theta. And that is what area equals. So let's start to read the prompt, okay? So the graphs of the polar curves r equals 3 and r equals 3 minus 2 sine of 2 theta are shown in the figure above from 0 to pi. So I know this is r equals 3 because the radius is 3 for all around the circle. And this is the other r because that's the only r that's left. For part A, it says let r be the shaded region that is inside the graph of r equals 3 and inside the graph of r equals 3 minus 2 sine of 2 theta, find the area of r. So I have to find out this area. The way I like to solve this is by just looking at the graph. I know I see a quarter of a circle right here, and I know that the area of a circle is pi r squared, and if it's a quarter, you would just divide it by 4. So let's just write that down. Part A, area equals pi r squared, so the radius is 3 for that circle, divided by 4. And now you have to look at this part right here. And I know that this equation is this r is r equals 3 minus 2 sine of 2 theta, and I'll just use the equation right here that is area equals 1/2 of theta 1 to theta 2 r squared d theta. So 1/2. And using the unit circle, you know that this is 0 and this is pi over 2. So 0 pi over 2. And then you know that the r is 3 minus 2 sine of 2 theta. And you have to remember to square it, d theta. So since you can use your calculator on this FRQ, pull that calculator out. First thing you want to do is store your r equation so you don't have to keep on writing it down. And then you just plug it in the numbers. So you know it's 9 pi divided by 4. And you add that to 1/2. Take the integral from using the r, and you know that you stored it right here. And don't forget to square it from 0 to pi over 2. And you get an answer of 9.708. So let's write that down. Alright, let's move on to part B. It states, for the curve r equals 3 minus 2 sine of 2 theta, find the value of dx d theta at when theta equals pi over 6. So I see that your endgame is to find out dx d theta, so I know that I need an x equation. Using what you know right here, you know that x equals r cosine theta, and you know you have to use this r right here. And you just plug in the numbers. Okay, and now you know since it's dx d theta, you know you have to take the derivative when theta equals pi over 6. So yeah, so x equals r cosine theta, and then so you plug in the r that you know, and it's cosine times cosine of theta. And then you take the derivative. Using your calculator, you can easily solve that. So you know you have to plug in when theta equals pi over 6. And now let's pull out that handy dandy calculator again and plug in the numbers. So you know that you can use your r again. Your stored r. Multiply by cosine of theta. And it doesn't matter if it's x or theta, it works both ways in this calculator. And you know you have to plug in pi over 6. And you get an answer of negative 2.366. Alright, put the calculator away and let's move on to part C. Part C states the distance between the two curves changes from 0 to pi over 2. Okay, so from 0 to pi over 2, the distance changes. Find the rate, which also means derivative, at which the distance between the two curves is changing with respect to theta when theta equals pi over 3. Okay? So, to find the distance, you just it's the top equation minus the bottom equation. And then you get the distance between this curve and this curve. Okay, so you know this is r equals 3, and this is r equals 3 minus 2 sine of 2 theta. So 3 minus 2 sine of 2 theta. And then you just simplify. And then it tells you to find the derivative when theta equals pi over 3. So plug in when theta equals pi over 3. So you found out what distance was, then you take the derivative when pi equals 3. Pull out that handy dandy calculator again. And so it's the derivative of 2 sine. You can do this by hand, but it's easier to just use the calculator because you might mess up but if you do it by hand. And you get an answer of negative 2. Alright, let's move on to part D. Part D states, a particle is moving along curve r equals 3 minus 2 sine of 2 theta, and then so that d theta dt equals 3 for all times, find the value of dr dt when theta equals pi over 6. So the first thing I like to do is write down what I know. So I know that d theta dt equals 3 and r equals 3 minus 2 sine of 2 theta. Okay, and it tells you to find out what dr dt equals. And so I know that I need to have a dr somewhere, so I know I need to take the derivative of r during some time during this problem. So I'll just do that just now. And you'll get an answer of negative 4 cosine of 2 theta. The reason why it's 4 is because I used chain rule and I multiplied it by 2. To find out what dr dt equals, I know I have to use this equation right here, and if I multiply these two together, so dr d theta and d theta dt, these two cancel out and you get dr dt. Wow. Okay, so I know that dr dt equals this times this, so that's going to be negative 12 cosine of 2 theta. And I know I have to plug in pi over 6, so I'll do that. and you'll get, plug in negative pi over 6, you get pi over 3. So I'll be using the unit circle, you'll get 1/2. And your final answer would be -6. So where the points come from this is that for part A, you get 1 point if you know the integral. If you know, you get another point if you know the limits, so for 0 to pi over 2. And you get 1 point if you get the final answer. So it's total of 3 points for part A. For part B, you get 2 points of total. So you get 1 point for the expression of x, and you get 1 point if you get the final answer. For part C, you get 1 point if you know the distance, the expression for distance, and you get 1 point if you get the final answer of -2. For part D, you get 1 point if you use the chain rule with respect to x right here, and you get 1 point if you get the final answer of -6. So that's a total of 9 points for this problem, and you guys have a great day.